All right, thank you for joining us today. And in this video, we are going to practice on sets what we just learned from the previous video. Don't forget, we said union, we can say or, and intersection, we can use and. So let's assume we have set A, B, and C, right? We have set A, B, and C. So let me put this note here. We are going to use intersection, and we are going to use and, we are going to use union, and we are going to use or. So that's one thing or two things that you need to put it in mind, like have this one in mind. Right? Anytime we are doing expansion, we are going to interchange them left and right, right? So let's assume that we have set A, B, and C, right? We want to prove that one, we want to prove that A intersection B is the same as B intersection A, right? So that's the first proof that we want to do. So how can we do this? First, for us to prove that this is the same as this, then what we just need to do is we are going to assume that X belongs to A union B, right? And good. Then we are going to have U this. So that's how we are going to do it. Then we also prove that X belongs to B union A and also belongs to A union B, right? So if you want to prove that something is the same, you need to prove that this belongs to this, right? And when you finish, you prove that this is also belonging to this. Or maybe somebody can use the if and only if, sign like this. If and only if. So if and only if, then it means that if I want to use the if and only if sign, then I'll just prove for this. But when I'm proving it, I'll just use this sign so that it actually take it back to from down to the top, right? So I'll use the if and only if, and I'll do for both of them too as well, right? So let's get started. So if I write this, then I'm going to start with the first one, right? So the first one is I want to show that um, this guy here belongs to this. So let's go to the process. What are we going to do? Now remember, union, we are going to use or, right? So let's get into. Okay, so we are going to have X belongs to A union B, right? So the next step is we are going to, so the next, what I want to do is I want to put this one in parentheses so that it can help us to know what we are trying to do. So as I said from the previous video, it's like you have A times, um, let's say B plus C. So if you want to do the distribution, then it will be A times B plus A times C. So that is the idea. We are trying to distribute this with A union this with the B. So that's what we are trying to do. So let's see what we can do. Now this is going to be X belongs to A. Now remember we said when we are expanding, we change the union to or, right? So this one will be or X belongs to B, right? Good. Now one thing that we need to remember, when we are using union is like addition, right? We are trying to add two things together, right? So remember, if I want to add A plus B is the same as B plus A, right? Commutative, right? So with this, I can reverse this and write it as X belongs to A, sorry, X belongs to B or X belongs to A, right? So from this order, I just bring this one here or I bring this one also here, right? So if I do that, then I can rewrite this one as, so look at what I'm going to do again. It's like me having something like A times B plus A times C, right? Now I can see that A is here, I can see that A is here, I can factor it out. I can see the multiplication here, I can see the multiplication here, I can factor it out. So here I'm going to factor A dot out. So when I factor A dot out, what will be left? B plus A dot out, what will be left? C. So we are using that idea to do this one. So here I can see that I have the x here, a member here, a member here. So I'll try to factor that one out. So I'll have x belongs to. So when I factor this one out, what will be left here? B. When I factor this one out, what will be left? A. So I'm going to have in bracket B. Then since we are putting them together again, we change the or to union, right? So union A. So this is what we are going to have. As we can see that now we've shown that if X belongs to A union B, then it belongs to B union A, right here. So we started with this one and we were able to do this one. So the next thing that we need to do is we need to start from the right to prove that is the same as the left. Or as I said, we can use the if and only if sign, right? So if and only if. So if I use the if and only if, it reverses it, because actually if I want to prove that this is equal to this, you can see that it's just writing this one first, followed by this one, followed by this one, followed by this one. It's just bringing this one on top. So let me see. So if I want to do that, is that I'm going to write this one first, because I want to prove from that place first. So I want to prove this one first. So I'm starting with this one, and this one is right here. So I'm going to have B union A, right? Then the next step will be this, right? As we are doing the expansion. So this times B, or this times A, which is right here. So it's like we are taking from down to the top. So this one will be X belongs to B union. Sorry, we are saying that when you are expanding, you change it to or, then X belongs to A. Then the next thing was we were able to swap the two, right? We brought this one here, we brought this one here. So this one, we bring this one here, we bring this one here. So this one is going to give us X belongs to A or X belongs to B, right? And what did we do? Here, after we've done here, we said, let's do factorization. So when you do the factorization, what is going to give you right here? What is right up there? So this one is, I'll factor X a member, and what will be left here? A. When I factor X a member, it will be left with B. But here, since we are putting them together, we are going to change this one to union, and then we have our B, right? So it's either you do this and this, right? And to prove that, okay, so since this belongs to this and this also belongs to this, then we can conclude that this is the same, right? Or you can use the if and only if, but it's always the best for you to do this. After that, do this, because it's just you are going to reverse it. But if you want to use the if and only if, that one too is also acceptable. You can use the if and only if. So now we can conclude that since X is a member of A union B belonging to B union A, X is a member of B union A belonging to A union B. Therefore, we are going to say that A union B is the same as B union A. Right. Good. So the next one that I'm going to take, you can pause the video, try and solve it yourself, and see if we are going to get the same results that we are going to have, right? So what we can do is, I want to pick similar one, but I'll just change the intersection, sorry, union to intersection. So I just want to do this. So you can follow the same procedure, pause the video, do it. When you finish, come and play the video and see if you had it right, right? So I'll continue solving, and you can pause the video to do that. So the same procedure is just like I'm going to have the same thing, but everything will change from union to what? Intersection. So X belongs to A intersection B belonging to, or belongs to B intersection A. Then I'll go with X belongs to A intersection, sorry, B intersection A, or belongs to B, or belongs to A intersection what? B. So I'll take them one by one from the top here. When I pick the first one, X belongs to A intersection B, right? And we are going to have, I'll put it into parentheses. I'll put it into parentheses. So I'm going to have X belongs to A, and so we are expanding, and this is intersection, so we put n, and then this one will be X belongs to B. So let's swap them. This one comes here, this one comes here. So we are going to have X belongs to B and X belongs to A. Is that right? And then now, since we're able to change it, now what we need to do is we need to factor X and element of belongs to any of them. So X out, this one, remember of also out, and this one will be B. Now, since we are putting them together again, we change the N to what? Intersection, and we are going to have something like this. So this is how it's going to be. Then we swap it by repeating everything by starting from this. So you can write this one first, followed by this, followed by this, followed by this in the next step, which is going to prove what is here. So we are done with the first proof, proving that this is inside this. So this is inside this. So if X belongs to this and X also belongs to this, then we assume that this everything is also here. So let's do the last one by repeating the order. X belongs to B intersection A, expand, X belongs to B, and X belongs to A. We change the order. X belongs to A, X belongs to B, right? And then what are we going to have? We factor X and belongs to out, A intercept B, right? And we can see that we were able to also prove that this is also in this, which is right here. So now we can conclude that A intersection B is equal to B intersection A. So very simple. All you need to do is remember that this is the same and you go through the process very nicely. Since we are done with the video, you can pick, example, like same example, you sit down and you practice, because remember, practice makes a man perfect. You need to practice to make sure that you are very good and you can go with the another question. So in the next video, we are going to talk about another example, which maybe I'm going to combine three sets like A, B, C, and we'll try to see how we are going to also prove that. See you in the next video.